We're going to look at finding the least common multiple of polynomials. So if these two polynomials were on the bottoms in the denominators of fractions, we would need to get a common denominator to add or subtract those fractions, or to clear out the denominators from an equation where we're solving. So we always need to find this common denominator. How do we do that? If these are just polynomials with no addition or subtraction in them, we can find the prime factorization. We can use a factor tree, and 4 will be 2 squared, and we have a 2 here and a 4 there, which is 2 squared. So our base is 2. So base is 2, and the highest power in any snapshot, in either of the snapshots, this one has the highest power, 2 squared. So we'll use that as 2 squared. We also have x's and y's. The x is highest power is here, second power. Highest power out of these two is cubed. So 4x squared y cubed is our common denominator. We'll do the same thing here. We've got 5, 15, and 10. And I can write each of those with their prime factorization. So what are the base numbers that we ever have? We have a 2, a 3, and a 5. In any single snapshot, here, here, or here, none of them are raised to a power. So we won't raise these to any other power but 1. So that gives us 30. And then we also had variables of x, y, and z. The highest power on an x was 2, right here. Highest power on a y, here, 2. Highest power on a z was just here as 1. When we look at these two, when we look in number 5, we've got an x by itself as a polynomial, and then this x minus 2, but that has subtraction in it, so we have to use this entire quantity right here, the entire quantity, as a base. So we've got an x, and we also have an x minus 2. Neither of them is raised to a power in their snapshot, and so this is our common denominator. We've got the same thing here. We've got x minus 1 and x plus 4. But these are hooked together with addition or subtraction, so they have to act as a unit. And so we'll have x minus 1 and x plus 4 multiplied together, and that makes up our common denominator. Looking in the next one, here I've got an x and an x minus 1 and an x squared, and then an x minus 1, the quantity squared. So bases are x and x minus 1. Right here I've got an x squared, so we need this one squared. The x minus 1 occurs twice here, so I need an x minus 1 squared. So there's my common denominator. I'm going to always factor these first. So I've got x minus 1, x plus 1. And this one, when we factor, is x plus 1 times x plus 1. I've got x minus 1 and x plus 1 as bases. And then this one, I've got 2 of the x plus 1s in it, so we all use x plus 1 quantity squared. In number 13, I've got a t. I'll factor the t squared minus 1, and I'll factor the t squared plus 5t minus 6. So the bases I have are t, t minus 1, and t plus 1, and then also a t plus 6. None of them ever are repeating in each snapshot. So they're all just to the first power. Excuse me. Here I factored again, and you might use the quadratic formula to find your factors for this one if you need to. And I've got a 4, which is 2 squared, but that's my only number that I have is 4, so I'm going to go ahead and use that. The 2 squared is 4. 2x minus 1 and 3x plus 2 are my bases. But in any snapshot, nothing is ever to another power besides 1. So remember, when you're working with common denominators, you want to take a look at them and see if you can factor first. Then see what bases you should have, and then look at each snapshot and see if anything is there as a base more than once. Like here it's twice, and then you'll get that base raised to a power. So for your homework, you're going to work on the problems on the other side of this sheet. Do them on a separate piece of paper, and they'll be due to be turned in on Friday. Thank you for listening.